Picking back up with section 7.1, let's look at a formula distance is equal to rate times time. Now, we probably use this all the time and do not realize we're using it. For example, let's suppose we have a car that drives, I don't know, 60 miles per hour for 2 hours. Okay? You could tell me how far it goes just off the top of your head. But we could use this formula. We could say the distance the car traveled, it was traveling at a rate of 60 miles per hour times it was traveling for 2 hours. In other words, rate times time. Then the hours would divide out and distance would be 120 miles. Okay? So we're going to be using this formula in this section. Let's see. Let's look at our example that's next on our notes here. This example is next. I'm not going to write this whole thing on the board, but let me read it. A plane leaves an airport heading south, 82 degrees east at 320 miles per hour. So let me draw a picture of this, okay? Let's suppose this is my compass here. This is north, south, east, and west, okay? Now, how's it say the plane is flying? South, 82 degrees east. So it's going southeast, something like this. And this angle right here is 82 degrees. 82 degrees right here. All right, so my plane's flying something like this, okay? All right, now what else does it say? It says after 1.2 hours, it makes a 90-degree counterclockwise turn. So if it's going counterclockwise, it goes this way, right? And it makes a 90-degree turn. So right here, we're going to have like a 90-degree angle. All right. Then it goes on to say, so a U bearing north 8 degrees east and travels for 45 minutes. All right, in part A it says, find the plane's distance from the airport to the nearest mile. All right, so what's going on here? Our plane went this way, made a 90-degree turn, went that way. Guess let me put an arrow right here. And then where it's at right now is over here. And let's look at where it's at in reference to the origin right here. Like right here. Okay? Now, what does it want me to do? It says find the plane's distance from the airport to the nearest mile. So how far is your plane now from this airport where it took off? Or how far are you from the origin to this plane? I don't know. Maybe I'll call that D, okay? Some distance. Call it whatever you want. X or whatever, okay? Now, all I know right now with my labels is that I have, this is D, and that is 82 degrees, okay? But doesn't it talk about how long it traveled right here? It says what? It traveled 320 miles per hour after 1.2 hours. So let's figure out this distance right here from this point to that point, okay? So I'm going to call that like my first distance. And we said just a minute ago that distance is equal to rate times time. So that first distance is going to be the rate at which the plane was flying right here, which it tells me was 320 miles per hour. 320 miles per hour. I'm going to exclude the units for now just to make it easier. And how long did it travel this way? For 1.2 hours. So you multiply those two, and you get D is equal to, what is it, 384? And the distance is going to be in miles there, 384 miles. So let's call this 384 miles from this point right here to that point right there. So that distance is 384, or we could think of that side of my triangle as a length of 384. All right, what else happened? This plane took a 90-degree turn and went that way for so long, right? So let's find this distance right here. I'm going to call that maybe my second distance. Second distance. So look at my second distance. Well, distance is equal to rate times time according to my formula, right? Now, what does it say about that second distance? It says it traveled for 45 minutes. It traveled for 45 minutes here. So I'm going to assume that it traveled at the same rate or the same speed, 320 miles per hour times time. And it said 45 minutes. But whenever I use this formula, rate times time, and if this is in miles per hour, I want the time to be in hours. If this is in miles per hour, I want the time to be in hours. If it says 45 minutes, isn't it 45/60th of an hour? Sure is. So we multiply that stuff out, and what do we get? Let's see, that's 320 times, how can I simplify that? I could say that is 3/4, right? And that would be what? 80 times 3 or 240. So distance is 240 miles. So that gives me this distance right here, 240. All right, so now I have my triangle labeled right here. Now, what is it asking me for? It's asking me how far is that plane from that airport that took off from. So it's asking me, what is lowercase d? All right, I have a variety of ways I could find this right now. One way is I could say the tangent of this angle is equal to that over that and so forth, okay? Actually, I don't even know if that's going to work here. No, that's not going to work here. So what am I going to do? Well, I have a right triangle. I know two sides, so I can use the Pythagorean theorem to find this d value. So let's do that. I'm going to be finding lowercase d. Finding lowercase d. How do I do that? Use the Pythagorean theorem. 384 squared plus 240 squared is equal to d squared, right? And if I solve all this and it tells me to round to the nearest mile, I'm going to get d is approximately equal to, let's see what I get. I got 452.8311. So if I round to the nearest mile per hour, I get 453. So to answer the question on part A, how far from the airport, I'm going to say 453 miles. 453 miles. So this distance here is 453 miles. All right, let's look at part B now. Part B says, find the bearing required for the plane to return to the airport, round to the nearest degree. So they want to know, what is the bearing this plane is going to have to fly back to be able to get back to the airport? Okay, let's think about this for a second. The plane's flying back along this dashed line right here, and this dashed line we could think of as continuing through here, right? So if the plane flies back going towards like this way, then which direction is it headed here? It's headed southwest. I just need to find the actual degree measure, right? All right, so let's see. Let's label some stuff here. All right. So I need to find out what is that degree measure in here, okay? Let me erase some stuff here. Give myself some more room. Let's see. Let me go ahead and shorten this a little bit. Now you're going to see on the notes I draw multiple pictures, which I encourage y'all to do. And I just don't have enough board space to draw multiple pictures here. But I like to draw multiple pictures and relabel stuff and so forth. Alright, so if from here to here is 82 degrees, what is this little acute angle right here between the x-axis or between the east axis and this ray right here? Wouldn't it be 90 minus 82? Or 90 minus 82 is what? 8 degrees? So I'm call that 8 degrees right there. All right. Now let me go ahead and find out what is this angle right here between the dash line and this ray that's labeled 384. Well, let me call this angle right here some kind of unknown. Maybe I can call it alpha, beta, theta, or whatever, okay? Let me see. In the notes, let me stick what I used with. In the notes, I used beta here, but it doesn't really matter what you call it, okay? How can I find a measure of angle beta right here? Well, if I have a right triangle, I could say that the tangent of beta is going to be 240 over 384, or opposite over adjacent. So I'm finding beta. So we said the tangent of beta is equal to 240 over 384. 240 over 384. Now, a lot of time there's more than one way to find what I'm finding here, okay? I'll just see this way first. So beta will be equal to the angle whose tangent, or the inverse tangent of 240 over 384 here. So let's see, if I put that in my calculator, make sure my calculator's in degree mode now, I get like 32.0054 degrees. Now what I like to do is I like to carry it out pretty far, at least 4 decimals, whenever I'm doing calculations with this number, and then round at the very end. All right, so that's what this beta is. This beta is about 32.0054 degrees, okay? Now let me ask you this. How could I go about finding what this angle right here between my dash line and this east axis is? Well, wouldn't it be all of this minus this amount right here? So it's all of beta minus this 8 degrees, right? So let me call that angle something right there. What did I call it in the picture? I called it theta. Called this angle between the east axis and this dash line theta. So I'm going to be finding theta now. Finding angle theta. How do I find theta? Well, we just said we take the 32.0054 and we're going to subtract 8 from that. What does that give me? 24.0054 degrees. Or I could say theta is equal to that. So theta right here is 24 degrees basically. I'm not going to write it yet. It's too crushed up right now. But isn't this angle right here also the same measurement as angle theta? Because those two are vertical angles right there. Then how do I go about finding this angle? That angle will be the complement of theta, right? The way I find that angle is I say 90 degrees right here minus this theta. So this whole thing right here is 90 minus that theta. And what did I call that in the picture? I called that angle alpha right here. So I'm going to be finding alpha now. Finding alpha. So how do I find alpha? I said alpha is equal to 90 degrees minus theta, which we said theta was what? 24.0054 degrees. And let me go ahead and round it to the nearest whole number here, because this is my last calculation with it. And what do you get? You get 66 degrees, right? Now, what does the problem tell you to do? It tells you to find the bearing required for the plane to return to the airport. So if you're in air traffic control, you got to tell them how to fly that plane. Well, you're flying at 66 degrees here, right? But what bearing is that? That's south 66 degrees what? West. All right, practice these problems. These are actually a little difficult whenever you get into the bearing, but practice them. Good luck.